Welcome everyone. Today we'll explore fundamental principles of chemistry beyond elements like krypton, chloro, bromine, and silver. First, we talk about the structure of atom, which is that the center of the atom has protons positively charged and neutrons neutral, no charge. Get orbit has electrons orbit around it, and electrons has negative charge. We have a periodic table, the metals. We have different groups of metals. Now we want to talk about the just two groups. On the left and the center we have metals. On the right we have non-metals. The metals further get branched to earth metals, like earth metals or transition metals. You have halogen on the right, group halogens and noble gases, alkali metals as well. On the periodic table, on the non-metals, as we go to the right, reactivity increases upwards. Reactivity increases for non-metals. For metals, it increases this direction, and downwards for non-metals. The reactivity, because of the tendency of losing or accepting, or losing or attracting electrons. Non-metals metals tend to donate electrons, to lose electrons, and metals like to attract electrons, and that happens on the outermost shell. We have shells or energy levels around the center of the atom. The electrons orbit on that levels or that shells. So the outermost shell either like to give or to attract the electron. We have the barium here. A metal is a solid metal. Also silver is a metal, solid earth transition metal. We have fluorine there, fluorine, gas, halogen gas, very electronegative, very active, and the barium is very active as well. Silver is very active. We have krypton, and inert. Has very low reactivity. Noble gas, inert gas. We have the electronegativity increasing up on the non-metals side, and increases on the direction right to the right. Non-metals electronegativity increases up and to the left when we go to the right direction. The electronegativity, as I mentioned, is a tendency of atoms to attract electrons. A tug it's called tug of war. So the strength of the tendency to attract electrons towards the atom. Non-metals has electronegativity more than metals. Metals like to lose electrons easily. So we have here different because of that attraction or attraction of electrons or the electrons, the electronegativity value leads to different kinds of chemical bonds. For example, you have metallic bond between the atoms of the metal. We have electrons. That electrons came because of that atoms lose the electrons and cause a sea of delocalized electrons surround these metal atoms. So there is a big attraction between the metal atoms and the electrons of the delocalized electrons, and it's very strong. The strength and it's very strong. This strength causes the metal to be very solid, so very solid in an arrangement. Looks like lattice, giant lattice structure. We have simple covalent bond also because of that electronegativity between non-metals, fluorine and fluorine. Sharing electrons because they have the same electronegativity, so no one is gonna of them is gonna lose its electron for the other. This is a reaction. Also, this is we have also ionic bond, and the ionic bond between non-metals and metals losing electrons and accepting or attracting electrons is a very big electronegativity difference that causes a very strong bond between barium and fluorine. Metal and non-metal loses the two electrons to two fluorine atoms gives us barium fluoride, BF2, and it's very strong. The difference is between 4 fluorine and barium 0.89, and it's solid in room temperature. The compound bonds. We have an interaction between the same atoms or the same molecules or the compounds of the substance, between them, not within the compound, between the compounds or the atoms or the molecules. These forces are very, very weak in comparison with the bonds, chemical bonds themselves. So how do that forces happen? The compounds or the atoms or the molecules, their electrons orbit around the center of the atom or between the centers of the atoms of the compound, get dispersed unevenly. A dispersion or dispersed unevenly, which causes the concentration of the electrons in a region is higher than the other region, which results in a positively charged region and negatively charged region. This leads to two poles, dipoles. positive and negative partially. And the same happens with the other same atom or electron, atom or compound, which causes an attraction, electric attraction between the oppositely charged poles. Dipole, 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 dipole attraction. Interaction, intermolecular forces. Some of that compounds have permanent dipoles, which means permanent forces. Some of them have induced or temporary permanent polarity, which leads us to the term of the London dispersion forces, induced Van der Waals. London dispersion force. And when we say Van der Waals, we mean the intermolecular forces, the weak ones in general. These forces are very weak, and that reflects the properties of the compounds or the substances. The substances. For example, because of the weakness of these forces, for example, HCl, hydrogen chloride, the liquid has a very low boiling point. Because of that, these forces between the HCl ones require a very low level of energy to overcome these, to break down these forces, which means low melting point and so on and so on. We have the other part of these forces, the bonds. For example, as we mentioned before, the metallic substances have bonds between the atoms, metallic bonds, initiating metallic lattice structure. These bonds are very strong, stronger than these weak forces. We mentioned this. Lastly, we have Vespa. The term Vespa, the structure, the shape of the chemicals, shape of compounds. For example, we have NH3. The theory is that the electrons around the center atom repel each other as much as they can. However, the lone pair of electrons repel the other covalent bonds electrons or interacting electrons, the reacting electrons, more than the repulsion of these reacting electrons to the other reacting electrons or shared electrons of the covalent bonds. So, for example, this NH3, we expect to have 360 divided by 4, 120 degrees between the bonds. However, we got only 107 because of this lone pair electrons has power to repel the others more, which means less degree. And we have hand out notes for trainees. This the first pages. Thank you. اللي هي